Okay, so this lesson focuses on common and natural logarithms, and this is part 3. So before you get to part 3, make sure you look at the lessons dealing with part 1 and part 2. Okay, so this is part 3 of our discussion on logarithmic functions and properties. So recall in one of the other parts, in previous parts, we talked about that this log equation, this log equation, y equals log of x base b, is equivalent to this exponential equation. And so remember, when we went from a log equation to exponential, we looked at the base first, and so here's the base, and so we said b to the y power, so that was your exponent on this side. See where it says b to y, and that was equal to the argument, which is x. So we did some problems like this in previous lessons. Now, let's talk about what a common logarithm is. So a common logarithm, and then we're going to talk about a natural logarithm. So a common logarithm, the logarithmic function that has base 10. So a common logarithm is a logarithm with base 10, okay? And it's called the common logarithmic function. Now, it looks like this. So when you write this as a function, it looks like this. So we say that the function f of x, which equals log of x base 10. Okay, see I have that base 10 right here? All right. So this is written as, so if you have base 10, now remember base 10 is called common logarithm. All right, so the common logarithm has base 10. Remember that word. Common logarithm, base 10. So the function f of x equal log of x base 10 is written as f of x equal log of x. Okay, now here's the thing. If you don't see a base listed, it's understood to be 10. All right, so no base. So there's no base listed. No base listed, it's understood to be 10. Okay? All right, so don't say, well, I thought if it's not listed, it's 1. Well, first of all, remember the base can be 1, right? So remember we talked about bases, base of exponential. So the base of exponential, base of logarithm can be any positive number. Okay, so any number greater than 0, and it cannot be 1. Okay? All right, so no base, what is it understood to be? 10. Okay, so log of x with no base listed means log of x base 10. Okay? All right, now let's look at some other properties with this. Okay, so a couple of things you got to remember, and that's this. All right, so if we look at this log right here, so log of x, and I have this base. All right, so question is this a common logarithm? No, this is not a common logarithm. So this is not a common logarithm. So this is not a common logarithm since the base is not 10, right? Because the base is 4. Since the base is 4. Okay, the base must be 10. Must be 10. All right, so make sure you understand that when you're looking at a situation, when you look at a log, you can tell whether it's a common logarithm, whether it's a natural logarithm, we haven't gone to that yet, or another logarithm. So this is a logarithm with what base? Base 4. Okay? All right, now, one of the things you had to do previously, was this. Okay, so previously you had to evaluate things like this. So number 1, we had log of 7 base 7. So do you remember what that is, log of 7 base 7, or do you remember how to actually find that is without using a calculator? In fact, you really don't know how to use a calculator at this point with this, but you remember how to do that? So what we did was we said log of 7 base 7 was equal to, and trying to figure this out, right? So remember we had to put the box there? And then we changed this to an exponential. So that's where this came into play. Okay? So that's how we went from a log equation to an exponential equation. And so we said 7, the base. Remember, we changed it. Take a look at the base first. So we said 7, the base, raised to this power equals the argument. And so if you look at this, if I want this side to be 7, then this exponent must be what? It must be 1. And so we looked at a property that said that if the base and the argument are the same, it's always going to be 1. So 7 to the first power equals 7, right? Okay. We also saw this. So number 2, we also saw that the log of 1 base 5, what do you think that, let me make sure and say that's 1. Okay, so then the log of 1 base 5, what does that equal to? Well, here's what we did as well. So we did the same thing. So we said, well, the log of 1 base 5 is equal to, I'm trying to figure that out. And so now I'm going to, since I wrote this as a log equation, I'm going to write this as an exponential. So I said 5 to the what power is going to equal 1. Well, 5 to what power is 1? Well, we saw that was 0, right? So that was 0. So that kind of makes sense, because if the argument's 1, regardless of what the base is, if the argument is 1, then that's going to be 0. The log of 1 is 0, no matter what the base is. This could have been 500. This could have been 22. Regardless of what the base is, that's going to be 0. Okay? So now I want to look at this in terms of common logarithms. So let's look at this. Evaluate this. Okay, let's write this as number 3. Okay, evaluate number 3. Okay, now, okay, so let's say we had this, log of 10. Okay, log of 10. All right, now, some of you, you're going to look at this and you're going to say, all right, so if I want to evaluate this, I'm going to do the same way I did this. I'm going to write a little box on the other side. Okay, well, okay, we can do that. So let's say log of 10 equals box, right? Okay, no big deal. We can handle that. And then we changed it to an exponential equation. Well, if I'm going to change it to an exponential equation, I need to look at the base first. All right, now let's talk about this. What is the base right here? You don't see a base listed. What is that understood to be? Well, that is understood to be 10. And so now we're dealing with a common logarithm. So this is a common logarithm. So a common logarithm has what base? A common logarithm has base 10. Okay? So now in my mind, I say the base, which is 10, raised to this power, is equal to 10. So 10 to the what power is equal to 10? Well, same thing here. 7 to what power equals 7? 7 to the first power equals 7, right? So that has to be 1 here. So that's a 1. So what's the answer? 1. Okay? So what you do with common logarithms, you do the same way you did with one of the other parts to this lesson. You do the same way. You're using this property. Okay, number 4. All right, suppose we had log to the 1,000th power. I'm sorry, log of 1,000, excuse me, log of 1,000. All right, well, let's think about this. So I'm going to change it to this. I'm going to say log of 1,000 equals box. All right, so I wrote this as an equation, so therefore I could use I can change it to an exponential equation. So what's the base? What's the base understood to be? Base is understood to be 10 because this is a common logarithm. So 10 to the box equal 1,000, right? Okay, so then you're going to ask yourself, all right, so 10 to what power equals 1,000? Many of you know this by now. You know what that exponent is. So 10 to the first power, you know that's 10. 10 to the second power, you know that's 100. 10 to the third power is what? 1,000. So you know that's supposed to be 3. In fact, if you want to write it like this, like where the two sides have the same base, if you want to like this, you can. For instance, see right here? So that's 10 to the box equal, and I can write 1,000 as 10 to what power? The third. And so then the exponents have to be equal, right? So then this has to be 3. So that's 3. So 10 to the third equals 1,000. All right, number 5. Number 5. All right, so number 5, let's suppose we had this. number 5. Okay, suppose in number 5 I had this then, log of 10 to the 8th power. Log of 10 to the 8th power. All right, no big deal. It's the same thing you did in a previous part. All right, using the same idea. So I'm going to go ahead, I'm going to change this to an equation so I can use this property right here. So I can use that. So in other words, I'm going to say log of 10 to the 8th power equals box, right? Now remember, we're dealing with a common logarithm because the base is understood to be 10 here. So I get 10 to the box equals 10 to the 8th power, right? So 10 to the box equals argument. Well, if the base is the same, then what must this be? If I want this side to equal that side, and this side's 10 to the 8th, then this must also be what? 10 to the 8th, right? So 8 goes here, so the answer is 8. Okay? Number 6. All right, number 6, suppose we had 10 to the log of 14. 10 to the log of 14. Okay, now, you got to remember how we did this in a previous part. All right, so what we did was this. So we first of all rewrote this as 10 to the log 14 equal box. Now what you have to think of this here is this. So you see how we thought of number 5 as a log equation, and we changed it to an exponential, and we did number 4 same way. We thought of this as a log equation, and we changed it to exponential. We thought of this as a log equation, changed it to exponential. You got to think of this as an exponential, and you're going to change it to log. Change to log equation. Okay? So we're going to go backwards this time. All right, so I'm going to change the log equation. I need to do this. Okay, so I'm going to write, remember we always write equal log first. Okay, what's the base right here? Well, the base is this base here, which is 10, right? Okay, so you'd say 10 to what power? So what goes here? Well, this exponent goes here. Okay, no big deal. I can handle that. And then this is your argument. That goes here. Okay. Well, look, so you want these two sides to be equal, right? The left side equal the right side. Well, remember I put a 10 here because this was a 10, but isn't that 10? Isn't this right here the same thing as saying this? Because if I don't write it, it's understood to be 10, right? Okay. Well, if I want those two sides to be equal, and this is 14, then this must be what? 14. Good. So that must be 14. So box must equal 14, right? Okay, so that's 14. But I want you to remember about some properties we talked about before. All right, so let's talk about some properties now. Let's remind ourselves about some properties that we had discussed earlier. So we're going to look at some general properties. Okay, general properties. All right. So in general, do you remember now with all that we've talked about, number 1, if I have the log of 1, regardless of what the base is, what is that equal to? If I have the log of 1, regardless of the base, what's that equal to? Well, let's think. B to what power is 1? 0. So if the argument's 1, regardless of the base, that's equal to 0. So then if I look at this in terms of common logarithm, isn't that the same thing? So in terms of common logarithm, if I have the log of 1, that should be what also? Well, that should be 0. Because that's understood to be 10. 10 to the 0 power equals 1. Number 2, if I have the log of b base b, what is that equal to? Well, let's think about it. B to what power is itself? B to what power is itself? B to the first, right? So that's 1. So then the same thing applies with common logarithms. So remember, common logarithms, if you don't see the base, it's understood to be 10. So common logarithm has what base? Base 10. So remember, that's base 10. All right. So then, according to this, if I have the log of 10, right? Then that's understood to be 10 to what power is 10? 1. Another property we saw was this. If you have the log of b to the x power base b, okay? So the log of b to the x power base b, what's that equal to? Well, that goes back to and I didn't do an example in here, but we could. So let's review our example. So if I have the log of 6 to the fourth power base 6, let's say, all right? And so I'm going to change this to an equation. So log of 6 to the fourth power base 6 equals box. Let's change this log equation to exponential. 6 to the box equals the argument 6 to the fourth. Well, since the bases are the same, then what must this equal, this box? Well, if I want these two sides to be equal, and if this is 6 to the fourth, then this must be 6 to the fourth. So box must be 4. So we saw in a previous part that if the base of the argument is the same as the base of the logarithm, then the answer is just the exponent. So then that would just be 4. So then this becomes b to what power is b to the x? It's just the exponent. It's just the exponent. So then in terms of logarithm, then I can say this. The log of 10 to the x power is just what? It's just the exponent, because this base and this base are the same. It's just x. It's just the exponent. And so number 4, we have b, and that goes back to this one now. So we have b to the log of x base b. So notice that the log expression is in the exponent now, but notice that this base and this base are the same, so it's just the argument. So that takes us to the common logarithm. Same idea. This would be 10 to the log of x. So this base is 10, this is 10, so it's just the argument. Okay? All right, so mainly for common logarithms, you just have to know that if you don't see a base, it's understood to be 10, and you evaluate this just like you would previous parts. Okay? All right, now let's talk about natural logarithm. So common logarithm has what base? Base 10. Let's talk about natural logarithm. All right, natural logarithm. Okay, so natural logarithm. Okay, so a natural logarithm is a logarithm with base e. Base e. A log with base e. Okay? So that's the log with base e. And we talked about the letter e, or I should say the number e, previously. All right, so the natural logarithm is a log with base e. And so if we kind of write this the same as we did with a common logarithm, we would say this. The function f of x equal log of x base e. See, the base is e, right? Okay. Is written as f of x equals, all right, now here's where you got to remember this. See where when the base is e, I wrote as log base e, log base e. We prefer to write like this. Remember, that's called natural logarithm, right? So that's going to be ln. ln, so natural log. ln, natural log of x. So if you see ln, that's a natural log with what base? Base e. So these two are the same thing, except we don't write it like this. We write it as ln. Okay? So we use ln. All right, so I need to remember this. You need to remember this now. Remember log of 5 base e means ln of 5. Okay? So remember, ln of 5, natural log of 5, this is natural log of 5. Natural log of 5 has what base? Base e. Has base e. Okay? as base e. So you have to know how to write a natural logarithm. So it has to be written as ln, okay? ln. So this means this, okay? That's going to be important to remember. Okay, now let's look at some examples. So our examples will be very similar. Our examples will be very similar to how we evaluated common logarithms. Now we're going to evaluate natural logarithms. The process is the same. You are going to use this idea. Okay? You just have to know that ln, the letters ln means natural logarithm. And it's understood to have base e. Okay? All right, so let's look at some examples. So let's evaluate. All right, evaluate. Okay, so the first one. Let's suppose I had, and let's call this number 1, the natural log of 1. Okay? So remember, what base is this? This is base e. All right, so we're going to do this. We're going to do this just like we did this. We're going to change this to an equation, a log equation, and then we're going to change it to an exponential. So we're going to first of all write it as a log equation, and then we're going to change it to exponential. Okay? All right, so I'm going to go off to the side. I'm going to say, all right, I want to know what the natural log of 1 is. So the natural log of 1 equals box, right? And so I know that the base is understood to be what base? E. So I'm going to change this to an exponential equation. So change to exponential equation. And so when I do that, I'm going to get e to the box equal 1, right? Well, e to what power is 1? Well, you've done that before in many previous times. Right here, let's see right here. Let me find the one that says 1, I'm sorry. Right here, so right here. So remember we said 10, so 10 to what power is 1? 0. So same thing. So remember we said that whenever the argument's 1, what's that equal to? That's equal to 0. So 10 to the 0 power is 1, so that's equal to 0, right? Okay, same thing. It's just that this base is e instead of 10 or instead of 4 or instead of 7 and so on. All right, number 2. All right, number 2, let's suppose we had this, the natural log of e to the 7th power. Natural log of e to the 7th power. Okay, no big deal. I can handle that. Let's change that to an log equation. So that's going to be natural log of e to the 7th equal box, right? And so the base, you don't see a base here. What's that base understood to be? The base is understood to be e. Now remember this right here. So I need to remember this. Ln, remember, is log with what base? E. So that ln means this. Okay? And so basically you're saying the log, ln, the log of e to the 7th with what base? E. That's what you're saying. So this right here, ln, is this part right here. That's what that is. So you're going to say e to the box is equal to e to the 7th. All right, well, if I want this side to equal to the 7th, then this exponent must be what? 7. So that's 7. Kind of makes sense because one of our properties, if you look at this, one of our properties right here, if the, let me go ahead and write right here. So you see we're dealing with ln, right? Natural log. So if the base of the argument is the same as the base of the logarithm, then the answer is just the exponent, right? So it's just 7. All right, number 3. All right, number 3, suppose we have, let's see, suppose we had the natural log of e, the natural log of e. Okay, well, we can handle that. I can change that to a log equation. So there'll be the natural log of e equal box, right? And so let's change that to an exponential. So if I change that to an exponential, remember ln right here means log base e, all right? So I'm going to say e to the box equals e. Well, e to what power is e? E to the 1st, right? So e to the 1st. So this is 1. Okay? And it kind of makes sense from number 2. So if the argument is the same, if the base of the argument, if the argument is the same as the base, then it's just 1. And that's what you're saying here. So you see, when you have the natural log of e, you're saying that the argument and the base, which is e, are the same, so it has to be 1. Okay, number 4, suppose you have let's say you had e raised to the natural log of 5. E raised to the natural log of 5. Okay, well, I can handle that. I can change that to a now remember, this is exponential, so I can change that to an exponential equation now. So you're going to say, and guys, that goes back to this one. So remember, we said that whenever the exponent contains a logarithm, and that base is the same as that base, then it's just the argument. And that's where we saw this, remember? So remember, log of x, so the base is 10, understood to be 10, this is 10, so the answer is just x. So then when I do this, most of you already recognize that's going to be 5 as the answer, but let's see why. So you're going to change that to an equation, just like this. And then you're going to change to a log equation now, because this is written as an exponential. Your exponent contains a logarithm. All right, so we're going to have, if I change that to log equation, remember, did I say L equals log? Just do log for right now. That base is this base. So you're going to say e. So e raised to what power? What goes on this side? ln 5. Natural log of 5 and natural log of 5. And you put the box here. That's your argument. Well, remember, this right here means natural log. So I just rewrote log base e as what you're supposed to write it as, ln. So now notice these two sides. I want this side to be ln, natural log of 5. So I need this to also be natural log of what? 5. So box must equal 5. So that's 5. Okay? So one of the properties you saw previously in our general properties was that if the base so your exponent contains the logarithm. So if the base of the logarithm and the base here are the same, then it's just the argument. It's just the argument. And that's what you're seeing here. Okay? All right, number 4. All right, so number 4, let's suppose in number 4 we had this. Okay, number 4. All right, number 4, let's suppose we had natural log of e to the 7x. Natural log of e to 7x. All right, now most of you should be able to tell me what this is right away. You should be able to tell me what this is right away. That's 7x. All right, so what is it? What do you think? All right, well, doesn't it kind of look like this example we did a while ago in let me see if I can find it. Let's see. Right here where we had the natural log of e to the 7, what was that? That was just 7, right? It's just the exponent. All right. Now, if you didn't, so many of you probably recognize that was going to be 7x. Okay, well, it is 7x. Now, if you did not recognize that, then just remember, let's go ahead and change it to an equation. So I have the natural log of e to the 7x equals box. I want to see what that equals to. Well, I want to change this log equation to an exponential. Change to an exponential equation. So remember, to change it exponential, you got to look at that base. So remember, ln, this right here, means this. So this right here means log base e of e to the 7x. So that natural log that I have circled, those letters I have circled means this. That's what that means. Okay? Now, if I want to change this to an exponential, I would say the base, which is e to the box, equals the argument, which is e to the 7x. So if I want those two sides to be equal, and this is e to the 7x, then this must also be e to what power? 7x. Okay, so the box must equal 7x. So that's how we got that. All right. Number 5, suppose we had the natural log of the natural log of 1 over e to the 5th power. Okay, now, that one may be a little bit more challenging for you, but let's think about that. The natural log of 1 over e to the 5th power. So I'm going to go ahead and change this to an equation so I can use that property. So I'm going to write this as the natural log of 1 over e to the 5th equals box. Okay? All right, now let's think about this. So I know that natural log, the letters ln mean natural log, which understood to be with base e, right? So if you need to in your mind, you think about it this way. So this right here means this, log base e, log base e. And so this is 1 over e to the 5th, okay, equal box. And so if I change this to an exponential, equation, I'm going to get e to the box is equal to the argument 1 over e to the 5th. Okay? All right? Now, in the previous problem, it was very easy. It was very easy at this point when I wrote it like this. At that point it was easy to determine what that exponent was going to equal. So if the base is the same, then the exponents have to be the same. So if I want this to be e to the 7x, then this has to be e to the 7x. So the box had to be 7x. So this has to equal 7x. But I don't have it written like this at this point. See, I don't have e to the box equal e to a number. I have 1 over. Well, you got to remember, you have to recall this. 1 over e to the 5th means the same thing as e to the negative 5th. All right, so you have to remember stuff about negative exponents. So e to the negative 5th means 1 over e to the 5th. So I'm going to rewrite this as e to the box equal e to the negative 5th. And now that looks like that. So if I want this side to be e to the negative 5th, then this must be equal to what? E to the negative 5th. So the answer is negative 5. All right, but notice the thought processes we went through. Okay, the thought processes we went through. Okay, number 6. All right, number 6. Suppose you had the natural log of 1 over e to the negative 3rd. Let's look at that one. The natural log of e to the 1 over e to the negative 3rd. Okay, we can deal with that. If you need to, do it this way. Rewrite it. So I'm going to rewrite this as a log equation. So natural log of 1 over e to the negative 3rd equal box, right? All right. And so I know that natural log means log with base e. Okay, so I know that. So I'm going to change this to an exponential equation. And so if I change this to an exponential equation, I got to remember that this natural log means log base e. So I'm going to say e to this power is going to equal the argument 1 over e to the negative 3rd. Okay? And so I'm going to rewrite this side with base e. Okay, so remember, if e to the negative 5 is 1 over e to the 7th, right? If e to negative 5 is the same as 1 over e to the 5th, and 1 over e to the 5th is this, basically remember what happens when you deal with exponents is that when you take this and bring it to the numerator, the sign of the exponent changes. All right, so in other words, let's kind of go a little bit further. In other words, if you remember the property from a previous course, 1 over a to the b power means a to the negative b, all right? And then 1 over a to the negative b power means a to the b. So whenever you go from denominator and bring it to the numerator, the sign of the exponent changes. Same thing here. So if the exponent was negative in the denominator and move it to the numerator, the sign changes. Okay? And the same thing here. Just remember, if I have 3 to the negative 2nd power, then that means 1 over 3 squared. So when I bring this to the denominator, the sign of the exponent changes. And so if I have 1 over 4 to the negative 3rd, then that is the same thing as 4 to the 3rd. Okay? So these are all things from previous courses in terms of negative exponents. So the point being this. So this right here, I can write 1 over e to the negative third as e to the third. That's what that is. So e to the box equals e to the third. So if I want this side to be e to the third, then this has to be e to the third. So the box must equal 3. So this is 3. So that was a little bit complicated. I agree with that. That was a little bit complicated, but just think of your thought processes as you went through the process, and you had to remember some things about negative exponents. Okay? All right, and then let's look at this, just kind of review another one. So let's say we had e to the natural log of 7x squared. E to the natural log of 7x squared. Okay, well, that goes back to this that we had here, remember? So e to the natural log of 5, well, that's just equal to your exponent, right? I'm sorry, to your argument, correct? Same thing here. So when I look at this right here, I want to see what that's equal to. Most of you probably already know that's equal to what value? Okay, 7x squared. All right, so let's go ahead and actually do the work so you can see this. So I have e to the natural log of 7x squared equal box, right? Now notice though that this is an exponential. My log is in the exponent, so that's an exponential. So I want to change it to a log equation. Change to a log equation. So I got to say equal log. Now remember that base is this base here. So what goes here? E. So we say e to what power? So what goes here? Natural log of 7x squared. And then what I'm taking the log of? I'm taking the log of this. But you got to remember that this right here that I'm circling, log base e, that's the same thing as, say, natural logarithm. So it becomes the natural log of 7x squared equal the natural log of box. Well, if I want those two to be equal to each other, I have the natural log of 7x squared equals the natural log. Well, what goes here? 7x squared. So box must be 7x squared. So that's what goes there, 7x squared. Okay? All right, now, so let's go back. See where I had those general properties here? Those general properties. So let's do the same thing, and I did the common logarithms. So let's do the same thing with natural logarithms, okay? All right, so I'm going to kind of put 2 pages on the side of each other to get us to see this. All right, so listen to what I'm about to do. So a while ago I had the general properties, right? And then the common logarithms. Now I'm going to put the natural logarithm here. All right, so this is going to be natural logarithm. All right, so let me kind of do this right here. All right, so remember the natural logarithm has what base? Base of e, right? Okay. So number 1, so if I have the natural log of 1, so if the log of 1 is 0, right? Log of 1 regardless of the base that's 0, so that means the natural log of 1 has to be what? 0, right? Number 2, what if I had the natural log of e? Well, same thing here. If the argument and the base are the same, it's just 1. It kind of makes sense because remember, natural log, that ln is understood to have base e. So e to what power is e? E to the first. All right. Number 3, then the natural log of e to the x power. So same thing here. That base and this base are the same, so it's just the exponent. That base and this base are the same, it's just the exponent. So the exponent's x, the base here is e, the base here is understood to be e, so that's just x. 4, if you had e to the natural log of x, all right, so remember the base here is e, the base here is e, it's just the argument. Okay? All right, so those were, this is how you deal with natural logarithms and common logarithms. And so I just want you to remember that basically a common logarithm has what base? Base 10. Natural logarithm has what base? Base e. And when we evaluated When we evaluated, we took into account that if the base isn't there, so it's going to be 10, and we used it when we went from log equation to exponential or exponential to log. We used the fact that if we had common logarithm, it was base 10. If we had a natural logarithm, like right here, it was base e. Okay? So I need for you to go back and review all this process right here. That's our thought processes that were written down. So you need to understand that these thought processes for natural logarithms, these thought processes for common logarithms is the same thought processes that occurred when we looked at this from previous parts. Nothing is different. It's just that with common logarithms, you're now dealing with base 10, and with natural logarithms, you're dealing with base e. Okay, so that's the end of part 3 of this series dealing with log functions.